Tonight, roughly 1 in 3 adults will set an alarm that guarantees them 5 hours of sleep or less. They will wake up, pour a cup of coffee, and tell themselves they feel fine. Inside the skull, a chemical called adenosine is stacking up like unpaid bills. Normally, a full night of rest clears it away, but at 5 hours, the brain never finishes the job. Leftover adenosine continues to cling to your neural receptors throughout the morning. This chemical buildup reduces your neural firing speed by as much as 15%. The brain is attempting to process information on a dying battery. After just 7 days, this persistent deficit forces the body into a state of biological emergency. Stress hormones flood the bloodstream at levels usually reserved for physical threats, causing insulin to stop processing blood sugar properly. This systemic alarm state causes your immune cells, the ones designed to hunt down infection and abnormal growth, to stand down. Deep inside the brain, your own cleanup crew begins to cannibalize healthy, functioning neural connections. By day 7, these cells actively dismantle your internal architecture. A week of short sleep creates a rapidly compounding multi-system emergency that impacts almost every organ in the body. Sleep is the most metabolically active and essential repair window the body has. During deep sleep, the pituitary gland releases a surge of growth hormone, or GH, to repair muscle tissue, strengthen bone, and regenerate skin cells. This chart shows how that cycle breaks. Cut your sleep to 5 hours and GH output drops by 70%. The body continues to age, but it has lost the majority of its cellular repair crew. While you sleep, the brain activates a waste removal network called the glymphatic system. It acts as a power washer for your neurons, but it requires the later, deeper stages of sleep to fully function. Cerebrospinal fluid rushes through the channels between brain cells, flushing out toxic proteins like beta amyloid, the sticky plaque associated with Alzheimer's disease. Waking up at 5 hours turns off this cleaning cycle before it can reach half the building. A University of Pennsylvania study found that after 14 days of 6 hours sleep, cognitive performance declined to the equivalent of being awake for 48 hours straight. Despite these numbers, the volunteers rated themselves as only slightly sleepy. The sleep-deprived brain lost the ability to accurately judge its own decline. This damage curve is exponential. Dropping from 6 hours to 5 causes certain functions, like memory, emotional control, and reaction time, to collapse by 40 to 60%. This leaves you like a pilot flying through fog who believes the sky is clear, operating in a state of severe impairment while feeling a false sense of security. 35% of American adults sleep under 7 hours. In the UK, it's 40%. In Japan, the average is just 6 hours 22 minutes. These numbers represent a planet-wide experiment in biological deprivation, where the results are ignored. Over the next 20 minutes, we will follow a single week of 5-hour nights to see how this experiment plays out inside your gut, inside your heart, and your immune system. To understand the damage, we have to start with the first 90 minutes of your next night's sleep. Missing that initial deep sleep stage will change the way you think and feel the very next day. Every time you set your alarm, you are choosing a specific and inescapable biological cost. The moment you close your eyes and drift off, your brain initiates a highly precise sequence of biological stages. Your muscles relax and your heart rate deliberately slows as the body transitions away from wakefulness. Within 10 minutes, you enter stage 2. Here, the brain begins firing rapid bursts of electrical activity, known as sleep spindles, which function as an active filing system to move information from short-term memory into long-term storage. The heaviest construction work occurs in stage 3, slow wave sleep. During this phase, long rolling electrical waves force millions of neurons to fire in perfect synchrony, resembling an entire stadium doing the wave. This intense neural synchrony acts as a mechanical trigger. It signals the glymphatic system to physically open its channels and begin flushing metabolic waste out of the brain tissue. The brain operates on a strict schedule of mechanical maintenance, requiring these filing and flushing protocols to reset itself for the next day. This chart illustrates an 8-hour sleep cycle. Deep sleep dominates the first half, while REM sleep concentrates in the second. Restricting sleep to 5 hours keeps your deep sleep, but effectively amputates your REM sleep. REM is where the brain processes emotional data. During a full night, the prefrontal cortex reviews the day's events and provides the necessary context to damp down the amygdala, effectively sending an all-clear signal to the brain's threat detector. On night 1 of restricted sleep, your REM cycle is cut by 40%. The prefrontal cortex never gets the time it needs to finish that calming review or deliver its signal. Brain imaging tracks the result. The morning after a short night, amygdala reactivity spikes by 60%. Irritability following a short night reflects a hardware failure. The threat detector remains hyper-reactive because it missed its nightly all-clear from the prefrontal cortex. By night 2, the effects compound. 5 hours of sleep provides insufficient time to clear adenosine, the fatigue chemical that builds up during wakefulness, leaving measurably higher residual levels in your brain by the second morning. Your body attempts an emergency compensation for this lingering fatigue by aggressively increasing its output of cortisol, the primary stress hormone. The liver detects this cortisol spike and reacts by dumping a surge of glucose into your bloodstream, interpreting the hormonal signal as a need for emergency fuel to escape a physical predator. Because you are likely sitting in traffic or at a desk, that extra glucose has nowhere to go. The pancreas must then release extra insulin to forcefully shove the unused sugar into your cells. After consistent short sleep, the cells begin to resist the constant knocking of insulin, dropping sensitivity by 25%. A 5-hour sleep schedule forces the body to handle sugar with the inefficiency of a pre-diabetic, even if your diet and exercise remain flawless. As you enter night 3, your immune system is actively monitoring this compounding biological stress. Your body relies on natural killer cells, aggressive frontline defenses that patrol your tissues for viral infections and abnormal cell growth, including early-stage tumors. By night 3 of a 5-hour sleep schedule, natural killer cell activity plummets by nearly 70%. After just 72 hours of a minor schedule change, your primary biological armor operates at less than 1/3 of its required capacity. Within 72 hours, your emotional regulation is compromised, your blood sugar control is deteriorating, and your immune system is standing down, all triggered by cutting 3 hours of sleep. The body refuses to remain passive under this strain and eventually initiates a defensive countermeasure known as microsleeps. During a microsleep, your eyes may remain wide open, but for 1 to 30 seconds, your brain entirely disconnects from reality. This biological override causes over 100,000 crashes and 800 deaths in the United States every single year. The nervous system initiates this hostile biological override to forcefully shut down consciousness without the host's consent. As insulin spikes, cortisol surges, and forced overrides push past the 3-day mark, the damage now moves deeper. By day 5, the next catastrophic shift occurs in an entirely unexpected location: your gut ecosystem. The communication channel between a sleep-deprived brain and your intestines represents one of the most critical, underappreciated frontiers in modern medicine. How many hours of sleep are you actually getting right now? Not the number you tell your doctor, the real number, from the exact moment you fall asleep to the moment you wake up. The gap between how much rest people think they get and what they actually get is one of the most consistent findings in human health research. If you restrict your sleep to 5 hours a night, the effects move completely beyond brain fog by day 5. The biological damage dives south, straight into your gut. Your intestines are home to roughly 38 trillion bacteria. These microbes act as a highly specialized, heavily active biological workforce. Every single day, they produce the short-chain fatty acids that physically fuel the cells lining your colon. They synthesize essential vitamins, including B12 and K2. They even manufacture roughly 95% of your body's serotonin, the neurotransmitter that regulates your mood, appetite, and sleep. Your gut and your brain maintain a constant dialogue through a bidirectional communication highway running along the vagus nerve. When your brain registers the chemical stress of sleep deprivation, it telegraphs that panic downward, triggering an immediate crisis within the gut's delicate ecosystem. By the 5th day of this continuous stress signal, your gut microbiome undergoes a literal population shift. The actual composition of bacteria living inside you begins to rearrange itself. On this 5-day timeline chart, we see a stark shift. The firmicutes population expands aggressively, overtaking the shrinking Bacteroides. This inversion is a biological red flag. A rising trend line and fat storage tracks precisely with the moment the firmicutes take over. Chronic short sleep physically forces your microscopic workforce to prioritize weight gain. Your body becomes chemically programmed to store fat, even if your daily calorie intake stays exactly the same. The mechanical structure of your intestines is also compromised. The lining of your gut is held together by structures called tight junctions. Think of them as the grout between bathroom tiles. Their job is to let useful nutrients pass through while keeping dangerous bacteria and toxins locked safely inside the digestive tract. Cortisol is the primary stress hormone, and it has been elevated in your body since night 2 of your poor sleep. Sustained cortisol actively weakens these tight junctions. Under continuous chemical pressure, that biological grout starts to crack. Once those fissures open, microscopic bacterial debris begins leaking out. Specifically, a highly toxic molecule called lipopolysaccharide, or LPS, slips through the broken barrier and enters directly into your bloodstream. Researchers call this condition metabolic endotoxemia. By mechanically breaking the physical barrier protecting your blood, your sleep debt triggers a steady, low-grade inflammatory response that radiates outward through your entire body. While your gut leaks, your heart absorbs the impact. Your cardiovascular system has been quietly dealing with that elevated cortisol and the resulting constricted blood vessels since the very first night you shortchanged your sleep. Under healthy conditions, your blood pressure drops by 10 to 20% while you sleep. This biological mechanism, known as nocturnal dipping, is absolutely essential. It gives the smooth muscle cells lining your arteries their only daily chance to relax and repair themselves. This line graph maps 2 distinct nocturnal blood pressure cycles. The first shows a healthy 20% valley during a full night of rest. Contrasted here is the cycle of someone getting just 5 hours of sleep. The restorative dip is completely eliminated. The clinical data reflects the danger of that flat line. Adults sleeping fewer than 6 hours a night carry a 48% higher risk of developing or dying from coronary heart disease. This risk increase occurs independently of exercise habits, obesity, or smoking. Operating on 5 hours of sleep forces your most vital organ to work a relentless 24-hour shift, entirely denying it any biological opportunity for structural repair. Fast forward to day 7. After a full week of restricted sleep, the accumulated damage reaches the core of your biology and becomes measurable at the genetic level. Blood analyses reveal that the expression of over 700 individual genes has been altered. The genes responsible for driving inflammation are turned up, while the genes tasked with immune defense and cellular repair are aggressively dialed down. Up in the brain, you experience a severe drop in brain-derived neurotrophic factor, or BDNF. This vital protein acts as biological fertilizer. Without adequate levels of it, your brain physically loses the chemical resources required to form new neural connections. This internal breakdown rapidly becomes visible externally. The combination of suppressed growth hormone and high cortisol accelerates the snapping and breakdown of collagen, the main structural protein keeping your skin firm and elastic. In just 1 week, a lack of sleep rewrites your body's operating manual from your DNA outward, stripping away your physical ability to adapt to biological stress. By this point, a dangerous illusion takes hold. Chronically sleep-deprived people often report feeling a strange second wind, leading them to falsely conclude their bodies have adapted to running on less rest. This comparative radar chart shows the objective reality. The large maximized shape represents a rested cognitive baseline, completely dwarfing the shrunken shape of a day 7 brain. Reaction times fall by up to 20%, and working memory is severely compromised. So what happens when the week finally ends? Can you simply repay this massive biological debt by sleeping a full 8 hours on the weekend? While your immediate energy levels and superficial systems might bounce back after a few days, the deeper molecular marks left on your cardiovascular system and gut microbiome can take weeks or even months to fully resolve. And then there's the final cost. In a desperate attempt to survive the chronic stress of continuous wakefulness, your brain's microscopic cleanup crew begins actively targeting and dismantling healthy neural connections. You never adapt to a lack of sleep. You simply become too impaired to realize. Most of us have played the sleep debt game. You scrape by on 5 hours a night, Monday through Friday, assuming you can just sleep in on the weekend and wipe the slate clean. Researchers call this recovery sleep. A long weekend of sleep does do some heavy lifting. Usually within 2 or 3 nights of adequate rest, your reaction times improve and you start feeling alert again. This happens because your brain clears out its backlog of adenosine, the chemical that builds up while you are awake and makes you feel drowsy. Once that adenosine clears, your prefrontal cortex comes back online. You can focus, you can hold a conversation, and you feel sharp. Your brain tells you that everything is back to normal. But feeling rested is a biological trick. That surface-level cognitive improvement happens incredibly fast, while deeper, essential systems inside your body are still heavily impaired and struggling to catch up. If we look past the brain and down into the bloodstream, the timeline for recovery looks entirely different. Sleep restriction severely disrupts how your body handles glucose. This animated timeline chart tracks a study from the University of Chicago. It shows exactly what it takes to repair impaired insulin sensitivity. The data reveals a strict 1-to-1 ratio. After 1 week of restricted sleep, participants required a full, uninterrupted week of recovery sleep, getting 7 to 8.5 hours a night just to return their glucose metabolism to baseline. The immune system is mapped right here on the same delayed curve. During a week of sleep deprivation, the activity of natural killer cells, the ones that fight off infections and abnormal cell growth, can drop by up to 70%. And just like insulin sensitivity, it takes a full week of normal sleep for those defenses to climb back to their starting point. This means that while you are going through that extended recovery window, your body is still actively operating with poor blood sugar control and weakened defenses. Cutting sleep short puts your internal systems into a prolonged state of metabolic and immunological vulnerability. You might wake up on Monday morning feeling entirely refreshed, but your cells are still paying off last week's debt. The damage extends all the way down to the molecular level. A week of short sleep actively alters the expression of your genes, particularly those responsible for inflammatory signaling. Unlike your reaction times, these genetic alterations do not vanish after a few nights of rest. A University of Surrey study found that even after a full week of recovery sleep, a subset of these gene expression patterns lagged behind, refusing to return to their normal baselines. Some people claim they are immune to all of this. They believe they are natural short sleepers. There is a genetic variant called DEC2 that allows a very tiny fraction of the population to function on 6 hours of sleep without measurable cognitive decline. But fewer than 3 in every 100 people carry it. Statistically, you almost certainly do not have this variant. Age compounds the risk. A developing adolescent brain is distinctly vulnerable because the prefrontal cortex is the last region to fully mature. Cutting sleep during teenage years causes deficits in emotional regulation and decision-making that outlast the actual period of sleep deprivation. Shift workers face a completely different biological hurdle. The suprachiasmatic nucleus, a tiny cluster of cells in the hypothalamus, acts as your body's master clock and responds directly to light. Sleeping during the day conflicts with this machinery, leading to suppressed melatonin production and highly fragmented rest, even if you stay in bed for 8 hours. Between aging, conflicting work schedules, and false beliefs about natural sleep abilities, most people are actively compounding an invisible, microscopic debt that accumulates deep inside the body. Let us return to the brain to look at a highly specialized type of cell called an astrocyte. Astrocytes are essentially support units. They feed your neurons, maintain the blood-brain barrier, and engulf and digest dead or unnecessary synaptic connections. Under normal, well-rested conditions, this process is called astrocytic phagocytosis. It is a highly beneficial housekeeping function. By trimming away the damaged connections, the astrocyte clears space for healthy neural pathways to strengthen. But a 2017 study from the Marche Polytechnic University in Italy revealed something alarming. In chronically sleep-deprived mice, this cellular pruning process shifted into hyperactive overdrive. This schematic compares normal astrocyte activity on the left with the sleep-deprived state on the right. Notice how the exhausted cleanup crew loses its ability to differentiate between cellular waste and active working neural infrastructure. Instead of just clearing out the dead branches, the astrocytes begin aggressively targeting and consuming perfectly healthy, well-functioning synapses. Chronic exhaustion triggers a state of sustained self-destruction. At the cellular level, the sleep-deprived brain physically dismantles its own living architecture. Halting the cellular destruction requires a reliable biological framework, and that framework is built entirely on consistent routines, not desperate weekend binge sleeping. The National Sleep Foundation recommends a strict baseline of 7 to 9 hours of sleep per night for adults, but duration alone is not enough. You have to lock in consistent bedtimes and week times, even on the weekends, to strengthen your circadian rhythm. This infographic tracks the essential environmental triggers for quality sleep. To signal daytime mode to your brain, expose your eyes to light, ideally sunlight, within the first hour of waking. On the other end of the day, reduce blue light from screens in the hour before bed to support natural melatonin production. Finally, there is a strict thermal requirement. Dropping your bedroom temperature to roughly 65 degrees Fahrenheit or 18 degrees Celsius promotes the core body temperature drop that actively initiates deep sleep. True cellular protection requires aligning your daily habits with the biological machinery your body already runs on. Keep in mind, this is general education, not medical advice, so consult a qualified clinician before making changes to your health routine. If this changed the way you think about sleep, subscribe to BioState.